In this question, we've been given the cumulative distribution function for a continuous random variable as shown below. We've been asked firstly to show that k equals 1/8. Well, looking at this distribution, there are two facts we should know instantly about the cumulative distribution function. If we substitute in the smallest value, we should get an answer of 0. And if we substitute in the largest value, we should get an answer of 1. So -3 in this function should give me an answer of 0. And +5 into this function should also give me an answer of 1. -3 wouldn't be so useful in this situation, and I'll let you have a look at the function to see if you can spot why. But substituting in the 5 is going to be useful. When we do, we get 8k equals 1, which leads to k equaling 1/8. Exactly what we were asked to show. In part B of the question, we're asked to calculate the probability x is less than 1. Well, that is exactly what the cumulative function does. It tells us the probability of having less than or equal to the value substituted in. So we'll substitute x for 1, and we get 4/8, 1/2. The probability x is less than 1 is 1/2. Part C, we're asked to state the value that p equals exactly 1. This is one of those questions where we need to look out for the wording. Any exact probability is always going to equal 0 from a continuous random variable. It's an infinitesimally small number. We just refer to it as 0. The question gave you some clues. It asked you to state. The command word state doesn't ask you to calculate or to show or to determine. State means you should know this already. You have enough information in front of you, or it's a fact you should know walking into the exam. The keywords, the command word state, lets you know to think twice, maybe think outside the box rather than starting to do calculations. In part D, we're asked to find the PDF, the probability density function of x for all values of x. So we would usually integrate to turn the PDF into the cumulative. We're going to differentiate to go the other way around. Differentiating this function is the same as 1/8 multiplied by the derivative of x plus 3. That gives us 1/8. The function in the PDF is simply 1/8, and that's in between -3 and 5, and it's 0 everywhere else. Part E asks us to state the name of the probability distribution represented by the probability density function that we found in D. Well, looking at that function, there are no variables in it whatsoever. It is just a constant value. If we were to sketch this, we know it's going to be a horizontal line in between -3 and 5. This is a continuous uniform distribution, something we should recognize when we see it in terms of a function. Part F asks us to determine expectation of x and the variance of x. If a student hadn't got part E correct, they would probably go about this the long way round. But since we know it's continuous uniform, we can make use of these two standard results. The expectation of x, a plus b divided by 2. -3 plus 5 divided by 2, the middle of those two numbers is 1. Variance of x, b minus a squared over 12. The difference between the numbers, well, that's going to be 8. 8 squared over 12, that's 64 over 12, and that simplifies to 16 over 3. The expectation and the variance, because we knew it was a continuous uniform distribution, we didn't try to make use of calculus or to integrate to get our way there. We turned this into probably 1 minute's work rather than 5 minutes work. Okay, so just being alert and on the ball while you're responding to exam questions.